Before we look at the graphs of the transformed sinusoidal functions, we're going to look at what happens to the key values. Now these key values will help us to graph the function later, and so that's why I want to talk about these first. This section is going to be a little bit just like follow the rules, which is not the way I like to do things, but you just kind of have to hold on to this, and then when we look at the graph later on, you'll see how everything fits together. So for now, we're just going to go through this very mechanical process, and then we'll see in the next video how these things come together to create the actual graphs of these things. All right, so here we have our equation, y equals a sine b t minus c plus e, our transformed sinusoidal, and here's our chart of key values for the sine function. When we transform the function, the sine function, we're going to transform these key values. And the question is, how are these key values going to be transformed? And again, very mechanical, you're just going to have to trust me for a moment. The first thing, this first key value, so the initial theta, or in this case I should use the letter t, initial t value. Well, this corresponds to horizontal shift, and so this will take the value of c. And so that key value will be shifted by a certain amount, and this c value corresponds to horizontal shift. The next thing we have to do is we have to get the spacing for the key values, and specifically for the t values. What's that going to be? Okay, so this formula is going to seem a little, we're actually going to calculate the period first, and then we want actually a quarter period because that corresponds to this. So the period is given by the formula 2 pi over b. And this corresponds to the idea that b corresponds to compression. So if b is equal to 2, then the period is half as long because you have to fit twice as many periods in the same amount of time that you did originally. So this is the formula for the period. And then the quarter period is just a fourth of this. So it's going to be 2 pi over 4b, which is also pi over 2b. And so this gives us the spacing to go from one to the next to the next to the next to the next. And then we have to look at the vertical values, which is this line down here. Now for the third one, we're going to look at the vertical values, the function values. And the idea you want to have here is you want to stretch, then shift. What does that mean? It means that you take this value here, you multiply by the stretch factor, and then you shift it. And so whatever this a is, you multiply this by that, and then you add d. So it kind of looks like this, a times y plus d. I shouldn't use the value y there. A times, I just put an empty bracket like that, corresponding to the value coming from that part. So you multiply your a and you add d. Now again, right now this is just a bunch of formulas. We'll do an example to sort of show you this, but it won't really be until the next video when we look at the graphs that all the ideas are going to come together. All right, so here is an example. Determine the key values of this equation, y equals 2 sine of 3 times quantity t minus pi over 2 plus 1. And I've written out the chart of key values for the sine function again over here. All right, so what do we have to do? So first of all, we're going to find the start point. In this case, the starting point comes from the horizontal shift, which is pi over 2. The second part we have to do is we then have to find the step size. These are the quarter periods. So first of all, we'll write down the period, which is 2 pi over b, which is 2 pi over 3 in this case. And then the quarter period is 1/4 of that, or you could use the other formula. I just like to think a quarter period here, so then the quarter period is going to be this over 4, which is 2 pi over 12, which is pi over 6. Right, and so this gives us, for the chart of key values, for our new function, 1, 2, 3, 4, and 5, our t values, they're going to start at pi over 2, and then they're going to take pi over 6 steps as you go to the right. Now, to make life simple, I'm actually going to, instead of write pi over 2, I'm going to write it as with a denominator of 6. That'll just make life easier. So this is 3 pi over 6, and we're just going to move by pi over 6 as we go to the right. 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6. Right, so that gives us all of our new coordinates, our new horizontal coordinates for the for our chart of key values. And our function which I'm just going to write f of t here so I don't have to try to fit that whole thing up here. For this, we're going to take these values, and the formula is going to be a times the quantity plus d. And again, we'll see where all this comes from later on, but right now just go with the formula. So here we go. What do we have? We've got a 0. So our a in this case is 2. Let me actually write this down. 2 times the quantity, and then plus d, plus 1. Right. So 2 times 0 plus 1 is 1. 2 times 1 plus 1 is 3. 0 we just did. 2 times negative 1. 2 times negative 1 is negative 2, plus 1 is negative 1, and then 1. And so this right here is our chart of key values. And we would then, to graph this, we would just plot these points, and we can use this information to create the graph. Now there's a lot going on here. Like I said, right now this is just follow the formula to get this chart. And then when we actually go through and graph these things, we'll see the connection that brings us all the way back to the basic concepts of transforming this function.